Hello out there to everybody, and welcome to this video today in our YouTube channel. In today's video we shall be looking at this proof. We shall be looking at how to show that the hyperbolic sine inverse of x is the same like the natural log of x plus the square root of x squared plus 1. So please, just for a quick reminder, please, if you are new to our channel, please, I highly plead on your behalf to subscribe to the channel and like this video, because that does motivate me enough. It actually tells me that you actually found contents like this so engaging and so useful, and I can only help you to pass all your exams that I promised initially I was going to do that if only you subscribe to my channel. And guys, please like the video and share it out with your friends. That way it is going to help them to locate our content. Thank you very much indeed. Let's get straight into the video now. Okay, now guys, to start by solving this problem, it will be so good for us to show that the left hand side is the same like the right hand side. By so doing, guys, we are simply going to let our y to be equal to the hyperbolic sine inverse of x. Because if we let y to be hyperbolic sine inverse of x, the most interesting thing now is that we can take the original hyperbolic sine y, or we can take sin y on both sides. We are going to have sin y to be the same like x. Now guys, let's recall that from definition, sin y is defined as what? 1/2 e raised to the power y minus e raised to the power negative y. Great. So guys, we saw that sin y is equal to what? X, right? And this sin y has what value? Has the value 1/2 e raised to the power y minus e raised to the power negative y. So now this quantity now has to be the same like what? X. Great. Now, so we have all this quantity now that has to be equal to x. So guys, if we multiply all through by 2, and we also multiply all through by if we multiply all through by 2, guys, we are simply going to have e raised to the power y minus e raised to the power negative y equal to 2x. Now, if we multiply all through again by e raised to the power y and arrange, we are simply going to have e raised to the power y, all that quantity squared, minus 1 equal to 2x e raised to the power y. If we now bring this guy now inside, we are simply going to have e raised to the power y, all that squared. Now this guy is positive, it comes in as negative. We have minus 2x e raised to the power y minus 1 equal to 0. So guys, from here now we can observe that this is a quadratic equation in terms of e raised to the power y, right? It's a quadratic equation. So if you haven't seen it yet, if you've not seen or recognized that this is a quadratic equation in terms of e raised to the power y, we can let our substitution, we can either let our y, our e raised to the power y to be what? M, capital M. Yeah, please don't ask me why I'm still using capital M, of which I used it last time, of which I used it before, but I prefer M because at least that's the beginning of my name. Yeah, that's the beginning of my Christian name as you have here. Yeah, you can use anything. You can use B, you can use A, you can use and so on and so forth. But guys, please don't use X and Y again, since in this proof we are using Y and X already. So don't use X and Y. Alright, now guys, if we substitute everywhere we see e raised to the power y by m, we are simply going to have m squared minus 2xm minus 1 equal to 0. So guys, we see that this is a quadratic equation in which we can easily solve using the using the quadratic formula method, right? Which says that m in this case is equal to what? Negative b. Keep in mind that our b in this case is what? Negative 2x. So negative of it simply gives us 2x, then plus or minus the square root of b squared. This is b squared. Now minus 4. A is what? 1. A is 1. The coefficient of m squared is 1. Then c is negative 1. That's why we have negative 1 here. All that over 2a. Our a was 1. So guys, now if we simplify a bit further, we are going to have our m to be equal to, now negative 2x, all that squared simply gives us what? 4x squared, right? Then negative 4, negative 1 gives us what? Positive 4. So we have a 4 here, and we also have a 4 here. If we factor out the 4, it comes outside of the bracket, but still inside the square root. The square root of 4 simply gives us what? 2. Why? The 2 comes out. these 2 and the 2 here and the 2 down, they can cancel. So we are going to have our x plus or minus the square root of x squared plus 1. But what was our m, guys? What was our m? Our m was what? E raised to the power y. So we simply plug in the value here, e raised to the power y equal to x plus or minus the square root of x squared plus 1. Now guys, if we take natural logarithms on both sides now, we are simply going to have the natural log of e raised to the power y equals to the natural log of x plus or minus the square root of x squared plus 1. Now guys, there's an important claim that we must make here. There's an important claim. What do we discover, guys? What do we discover? We discover that the square root of x squared plus 1, right, this is always positive, and it is always greater than what? X. The square root of x squared plus 1 is always bigger than x. Why? Because if you square the two of them, you're going to have x squared here. They are going to have what? Not just x squared, but x squared plus 1. So this quantity is definitely bigger than this guy. So we can lay our claims as follows. Okay, in this case now, this is going to give us our y to be equal to that. Okay, now guys, we can lay our claims as follow. This 3 stars here means this point is so important. It's super important. In the exam, if you're being asked to prove this identity, if you don't lay forth a valid proof like this, you will not be given the accuracy marks. You will not. So now our claim is that now the square root of x squared plus 1 is always greater than x for all values of x which belongs to R, but we can bring forth alright, for all values of x which belongs to R. That's great. So now we can bring forth some further conditions here by saying that we are going to have just one value of y here, just one value. We are going to take by the positive sign here, not the negative, because the domain of the natural log function is that all what is inside the natural log must not be less than or equal to 0, right? So now, if we must care about the interior of this natural logarithm, that therefore means that, and we know that the square root of x squared plus 1 is bigger than x, namely x is smaller than the square root of x squared plus 1. That therefore means that if we take x, which is a smaller quantity, minus the square root of all of this, which is a bigger quantity, we can see that this is going to give us a negative value. It's going to give us a negative value. That therefore means this guy is far more bigger than x. So we are going to have just one solution here, and consequently we'll see that the natural log of x minus 1, the square root of that will be what? Will be maybe there's an error here, guys. What I meant to say, x minus, that's the interior of this guy. What is inside the natural logarithm is less than 0, not the natural logarithm itself. Please just make this correction here. I'll see if I can do it, guys. Let me just see if I can do it right here. All right, so I'll just natural logarithms here. Okay, I'll just cancel it, guys. The natural logarithm is not meant to be here. Okay, so all that is meant to be here is simply going to be x minus square root of that is always less than 0. So it being inside the natural logarithm now simply makes our answer to be less than 0. So guys, the only answers in which we are going to take here is going to be the positive version of this guy, namely we are going to have, and we know that what is our y? Our y is what? Our y is sin inverse of x, right? So that therefore implies our sin inverse of x, the natural log of x plus the square root of x squared plus 1, as required, guys, as required. So this is the proof in which we have been asked to prove, guys. Thank you very much for watching, and I hope to see you in the next video, guys. Please, if you've not subscribed to our channel at this point in time, please, I highly encourage you to subscribe to the channel. You're missing a lot, guys. You're missing quite a lot. There are so many contents that we have here, but they are visible only to subscribers only. So guys, just hit the subscribe button so that you'll be able to see all the contents that you were not seeing, that are going to help you so much in your exams, and it's going to boost your understanding of the mathematical process. So guys, don't forget to like the video and put your comment. Just place your worries in the comment section, and I'm going to reply to them as soon as possible. Thanks for watching, guys, and have a great day.